3I Atlas is not just a comet. It's a cosmic anomaly whose extreme polarization and titanic mass are currently rewriting the rulebook of interstellar physics.
Mysterious visitors from the depths of the universe have always kept astronomers curious. These cosmic guests are rare objects born outside our solar system, traveling through the vast emptiness of interstellar space. The first discovered visitor was one ʻOumuamua in 2017. It was later followed in 2019 by the comet-like 2I Borisov. Now the attention of the scientific community is focused on the third interstellar object, the Atlas. But this new guest seems poised to shake our current understanding to its core, not only because of its existence, but also due to the unprecedented peculiarities it displays in its structure and its interaction with light. So, what is it about this third interstellar visitor that surprises the scientific world so much? Here are the latest updates about this unique guest. Before we begin, let me say that the data brought by 3I Atlas is truly puzzling. Especially its massive mass and the fact that we're seeing that polarization anomaly for the first time make us question everything we thought we knew. It feels like we're getting closer to Avi Loeb's not natural theory. Do you think all these coincidences, its close pass to Mars, its alignment with the ecliptic, even the directional similarity with the WOW signal, can really be just natural? Or could 3I Atlas be a turning point in our search for life in space? Share your thoughts in the comments and don't forget to like so more people can see this mystery. A new image of the comet 3I Atlas has revealed something truly strange. Scientists have discovered that sunlight behaves around this object in a way completely different from anything we've ever seen or imagined. This image was captured by the Mastcom-Z camera on NASA's Perseverance rover on Mars. In the photo, a faint, blurry dot is seen in the Martian sky where scientists expected the interstellar object 3I Atlas to appear. This marks our first glimpse of 3I Atlas from such a close distance. In the image, the comet shows up only as a faint smudge next to a group of stars about magnitude 8 in brightness. Another piece of data shows something moving across the Martian sky, which scientists believe to be 3I Atlas itself. Interestingly, this photo wasn't taken at the exact moment of its closest approach to Mars. The Perseverance rover captured it one day before. That, scientists say, the true closest pass could only be properly observed by Mars orbiters. However, due to NASA's current operational setbacks, it may take some time before detailed close-up images of the object are released. During 3I Atlas's close approach to Mars, the Perseverance rover also recorded increased surface activity. The image shows dust devils swirling around the rover and a massive dust storm forming on the horizon. The interstellar object's tail was too faint at that time to be visible in the rover's images. Scientists had already noted that this comet was unusual because it lacked a visible tail, unlike most comets. But as it approached Mars, it began to develop a thin tail, still much fainter and narrower than anything seen before. Other images show more detail about the shape of 3I Atlas, though they haven't been fully confirmed yet. According to these unverified visuals, the comet appears elongated, making it resemble the first interstellar object, ʻOumuamua, more than the second. 2I Borisov. The interstellar comet 3I Atlas passed very close to Mars on October 3rd, approaching within about 0.19 AU, roughly 28 million kilometers. It is now speeding through space at about 320,000 km/h, heading toward perihelion, its closest point to the Sun. But things took an unexpected turn. Astronomers believe 3I Atlas may have been affected by a coronal mass ejection, a huge burst of energy and particles from the Sun. After this solar event, the comet suddenly disappeared from view due to its increasing distance and the Sun's glare. Additionally, Earth's current motion in the opposite direction relative to the comet makes it even harder to spot against the bright starry background. As a result, 3I Atlas won't become visible again until later this year. Just when many thought it was an ordinary comet, new observations revealed unexpected anomalies in its structure and light behavior. These features challenge our current knowledge about such objects. Astronomers carried out the first polarimetric observations of the interstellar comet 3I Atlas. When sunlight travels through space and hits an object like a comet, it doesn't just bounce back straight, it scatters in many directions. Each tiny dust grain or ice particle around the comet acts like a mirror, changing how the light behaves. When light hits something, like dust around a comet, the waves can become more orderly. Instead of moving randomly, they start to align in certain directions. This alignment of light waves is called polarization. By measuring how much light is polarized and in which direction, astronomers can learn a lot about the dust it bounced off, its size, shape, smoothness or roughness, and whether it's made of ice or rock. When scientists observe comets, they usually find positive polarization at larger phase angles, and many comets show negative polarization at small phase angles. But when astronomers observed 3I Atlas, they found its negative polarization was extremely strong, stronger than in any comet ever seen before. This was a huge surprise. It means the dust grains around 3I Atlas are very different from those in comets of our solar system. With a minimum value of 2.77% at a 6.4-degree phase angle, its extreme negative polarization is unique among known comets. This strange behavior suggests that 3I Atlas formed in a completely different environment, possibly in another star system, or at the farthest, coldest, iciest edges of our own solar system. Scientists had previously claimed that this object is even older than our solar system. According to their research, it probably came from the inner regions of our galaxy, making it one of the oldest and most mysterious visitors to pass through our system. Another surprising observation revealed an unusual chemical composition around the object. The environment surrounding this interstellar visitor appears very similar to the atmosphere and surface conditions of our neighbor, Mars. This strongly suggests it may not have come from a typical comet-forming region, but instead from the surface of a planet with conditions similar to Mars. Some claim that this object shines in strange ways, not seen in normal comets. This could mean that as it approaches the Sun, it may evaporate more rapidly, or even break apart at perihelion. Scientists have observed other mysterious behavior as well. They noticed that while 3I Atlas lost mass and formed a visible gas cloud around it, its trajectory remained unaffected. Normally, when comets release gas, the ejection of material slightly alters their path, but 3I Atlas behaves very differently. Some scientists believe this unusual behavior may actually be explained by its enormous mass. The way it holds together even while forming gas clouds suggests it could be far denser and heavier than expected. Early estimates suggested 3I Atlas might be at least 1,000 times larger than any comet we've ever seen. Recent studies estimate its mass could exceed 33 billion tons, an almost unimaginable amount for a natural comet. And it's not just its size. Over the past decade, there simply hasn't been enough rocky material in interstellar space to deliver such a massive object into the inner solar system. Could this be another reason to think it's not natural? Yes, because the supply of rocky material per unit volume in interstellar space is limited. Recently, Professor Avi Loeb categorized all the unusual observations about 3I Atlas into two main groups: anomalies that could be explained in the future with more data. These include its size, its strange reverse tail, a beam of scattered sunlight pointing toward the sun and about 10 times longer than its width, its unusual chemical composition, and its strong negative polarization. Anomalies that may remain forever puzzling. These include 3I Atlas's orbital inclination aligning within just 5 degrees of the ecliptic plane, the plane in which all planets orbit. Another odd detail is that its timing of arrival appears perfectly tuned to pass near Mars, Venus, and Jupiter. Even more mysterious, the direction it came from aligns within 9 degrees of the famous WOW signal detected on August 15, 1977, which some scientists have speculated might have come from an extraterrestrial source. Professor Loeb argues that those who insist 3I Atlas is just an ordinary, naturally formed comet must bear the burden of explaining all these unusual coincidences as entirely natural. That's all for today. Don't forget to like and subscribe to stay updated on new developments about 3I Atlas. Have a great day, and thanks for watching.